All right, Mr. Bondley's daughter is riding her bike on the street. Of course, I want to find out how fast she was going, and of course, I do not own a radar gun. However, I could time her pedal revolutions per second, and then I can measure certain components of her bike. And let's figure out how fast she is riding her bike in miles per hour. All right, I'll start this problem by drawing a diagram. Well, we got our front sprocket here with a radius of 5 inches. We have our pedal connected to the sprocket with a radius of 8 inches. We have a rear sprocket back here with a radius of 3, and then our rear tire back here with a radius of 18 inches. Now connecting the front sprocket and the rear sprocket is a chain. All right. We know that there is an angular velocity of this front part of the system here. Okay. Now, if we know this angular velocity, we could transfer that to linear velocity of the chain, which we can then use to figure out the angular velocity of this rear sprocket, which is the same angular velocity of the rear tire. If we knew the angular velocity of that rear tire, we could transfer that to linear velocity of the rear tire, which will tell us how fast the bike is going. Let's start that then. Let's take this angular velocity of this front system here and transfer that to the linear velocity of this chain. 3.5 revolutions per second. Let's transfer it to some linear velocity, because the linear velocity of that chain will be the same as it goes along the front sprocket and the rear sprocket. However, these front sprocket and the rear sprocket will turn at different rates. All right, so we know that there are 2 pi radians in 1 revolution. We go straight to radians because we know that radians connects angular and linear distance, angular motion with linear distance. In this particular situation, there are 5 inches in 1 radian. Now, why did I use 8 inches? Because it doesn't matter in this particular situation. This 8-inch pedal length means nothing. It's just extra information. Well, if we do a little unit analysis here, we have inches per second, which is a linear velocity. 5 times 2 times 3.5 is 35 pi. Okay, this is the linear velocity of the chain, which is the same linear velocity of this rear sprocket. But the angular velocity is different because it's smaller. It's turning much faster than this front sprocket is. So let's take this linear velocity of this chain, let's convert it to angular velocity of this sprocket. All right, let's turn linear velocity to angular velocity. Well, I know that the radius of this rear sprocket is 3 inches, so there are 3 inches in 1 radian. We now have radians per second, which is an angular velocity. The angular velocity of this rear sprocket is the exact same angular velocity as this rear tire. Now that we know the angular velocity of the rear tire, we can transfer that to linear velocity. One radian this time is 16 inches. We now have inches per second. We have a linear velocity for the speed of the bike. However, I want the linear velocity in miles per hour. Now let's convert units from inches to miles. So there's 12 inches, 1 foot, and then 5,280 feet in 1 mile. We now have miles in the numerator. Let's Change seconds to hours. 3,600 seconds in 1 hour. Our units are now miles per hour. Let's calculate numerator and denominator. Looks like we have about 2,016,000 miles over, well, pi. Forget the pi. 3 times 12 times 5,280. So about 190,080 hours. Okay, there's a good step to check, see if our numerator and denominators are equivalent or the same as you guys are working the problem out. Actually compute this ratio and you should get approximately 33.32 miles per hour.